Actuality, Business Intelligence, the path to enlightenment.
Hello, Ira here. I'm going to give you my perspective and understanding of how AI works. A little bit of a voice problem, but it's allergies. It'll pass. I would like to offer my understanding of how AI works with my experience in BI and a lot of research. First, in my opinion, really AI is made up of several major areas. First and foremost is statistics, of which I have 20 years experience in. Secondly, it's algorithms. I also have quite a bit of experience. Patterns and data. Lastly, predictions. And of course, of recent and quite a bit of semantics. First, and I'd like to take a few minutes and help us get a common understanding of AI and, of course, BI, or traditional IT. There are many things that have to be done that are for the same results. So let's get started. First off, traditionally, there is a data governance framework that includes data governance, which may be managerial, may be technical. There are many components. Master data management, which is in the middle, and of course, metadata or data quality, which is produced by an application and has a repository and mostly administered by folks, stewards, clerks, managers, you name it. So, I'd like to spend a little more time talking about, on the left, the artificial intelligence framework. At a very high level, it consists of AI models, statistics, and then features and statistics. And how that relates, we will take some time and dive into. At the AI model, and the reason I have it relating to data governance is you have to define certain measurements, metrics, KPIs you want to predict or measure, which is the same logically in both. In the middle, on the side of AI, I have statistics, and in data governance, it's known as master data management or reference data. It's the same. Even in AI, we're going to have to relate features, statistics, and use statistics to prepare and clean the data. That is very similar. And then lastly, you'll notice in data governance, we have a metadata repository as well as tools to accomplish that. We also have here on AI features and statistics. One very fundamental aspect of AI or machine learning is that in IT, traditionally, you refer to data models and actual columns, fields of data. In AI, you refer to fields as features, and they can even be dimensions. We'll dive into that. So, briefly, we've been through traditional data governance, which you know something about, and we want to relate that to new deliverables out of your AI app. So, what we need to look at now is AI is a pyramid in essence, and it's a pyramid built the same way that data governance and AI relate. At the top, we have business requirements, which is critical that we nail down. Right below that, we have people, data stewards, shared service feature selection. Again, combining AI and BI. Next is precision tools, whether that's MDM or reference data or PCA in AI, principal component analysis. We'll go into details of how they work, but trust me, they're the same from a programmatic perspective. From a business requirement perspective, they're also the same, but they need to be explained and compared. You'll see on the left, we have measurements, fields, and features that have to be profiled and analyzed, statistics. And on the right, of course, we're going to have code or people with experience as to build an engine for this. You don't necessarily need to buy new products, but you need to understand how they correlate. Sorry. What I wanted to do was on the right, where you see people, is just point out that as we talk about features in AI, in data governance, IT, we will talk about dimensions. In essence, there can be confusion between both. We will help explain. So what we have here is I've built kind of a hierarchy of what we need to do, just so you can understand. And our experience in the templates and work products will need to gather with your help along the way. We have extensive experience. So again, whether it's AI or BI, we need business requirements. They will consist of, and we will build towards those: glossary and categories, business hierarchies, statistics, measurements for analysis and the model, and so that we can select the appropriate AI model, reports that exist that help us define, prep and clean the data, which again has to be business driven, model feature dimensionality reduction. We'll talk about that. That's to make our models run efficiently. An entity relationship model for if out of this we're going to build a traditional analysis or an IT app. Cost estimate, really for AI and IT. We want to know and have a roadmap and plan what's ahead of us. Misspelling here. Data searching. Again, what's important for us is to have effective searching. Many of these steps regarding profiling, data analysis, principal component analysis need to be orchestrated with complete business involvement and understanding. And again, we will help provide decision matrices for you. Do you need traditional for ETL for AI or IT for generative ETL? And again, we'll discuss different capabilities. They could include traditional AI, predicting outcomes, KPIs, or generative LLM, large language models. We will help you define both. And again, we would be able to get to the point where we had a complete understanding of the AI model execution or traditional model execution and what it will take for you to do that. Just a brief minute here. I'd like to talk about one of the things we'll help you do between machine learning of AI and IT is that there is a big difference between correlation and causation. And what happens is that the sun is hot And if we actually talk about correlation and causation, is the hot sun causing the ice cream to melt, or is it correlation? Also, is the hot sun causing you to get a sunburn, or is it correlation? It's interesting and requires definitive analysis to know what is the causation. Lastly, we'll take some time. We have used, and I personally have used for many years, a concept and methodology known as the information value chain. It was first created when I worked for Bill Emmons' company back in 1996. I've adapted it, and we're going to go through it right now. So first and foremost, you need to define the business goals. What are the KPIs that people will get fired for if they are not successful with your business? Of those, what are the measurements you actually want to understand? A goal can be very high level. An actual measurement was a little more nebulous. What are the categories? How do we categorize individuals for you to understand why you did or didn't meet your goal? Next, we have a method called measurement decomposition, meaning that we want to understand, especially to use machine learning or AI, is the data that we're producing, the rules we're creating, the results, the predictions, are they accurate? They can only be accurate if we understand what measurements are used to make up your decision. That will involve feature, field profiling. We will explain it more. Next, we're going to need to know the hierarchies. Exactly how is it related? If we want to drill down from a product category to a product, or if we want to look at the geography, what's in your North Division, what's in your South Division, or your org chart, we need to know the hierarchies. A critical part of data prep. Field feature analysis and profiling will be the input for this. Next, out of that, we'll produce a summary level data quality scorecard for your leadership to decide and understand where we're going. We'll be able to do AI model configuration or LLM. We will perform for BI functional dependency. In AI, it's principal component analysis. And if required, we would certainly be able to provide an entity relationship model. The last, you can see, we would have a pre-dive into the model configuration, the model training and testing. We will talk about the quality assurance and how that relates to model testing. You first have to make sure you've done feature and field data quality testing. And last, we'll provide the necessary requirements to either design. The following is an example of artificial intelligence, being me.
Artificial intelligence. Define correlation or causation. A very important difference. Artificial intelligence stems from a concept invented by Alan Turing during his work with the bomb, an early computer, in World War II. Needless to say, there are many aspects of today's AI. However, most of them are driven by various features and math formulas. Ultimately, data fields, are the primary drivers of AI and the concept of correlation or causation. In essence, they are represented in the graph by a line pointing upward or down a trend. If you involve two features, let's say, in the same general direction of the other arrow, and there is another arrow adjacent to it in the same general direction up or down, that can be interpreted either as correlation or causation. This is important in all fields. meaning that just because two things are happening and going in the same direction, or trend, they are correlated, but it does not mean one is causing the other. This is critical to understand. As a side note, we have made this mistake in history and science many times. Of course, this is another reason to base your science on standardized, verified, human curated information, not just raw data, or data manipulated by algorithms to make them conform to a model usable by AI. As you see from the diagram, including melting ice cream, it's not the cause of a sunburn, it is simply correlated.
I'd like to take a second and show you and talk about the similarities. So in the beginning, we have business goals, which are in the center. And you'll see to the left and right, we have artificial intelligence and business intelligence. On the business intelligence side, which we've done traditionally, there are business dimensions or categories, and below there are business metrics or KPIs. They consist of catalog categories, business KPIs, hierarchies, and validate business. We'll go into this in the future in detail. On the left-hand side, in AI, we have features. Those also consist of fields from tables, and similar to business dimensions, they can be grouped. We also have underneath that AI predictive metrics and AI generative content. And you'll see to the left, feature selection is part of that, and prompt selection. If you go down, you'll see that algorithm selection is similar and synonymous with metrics, and validate alignment to business is critical. In AI, it's similar to reinforced learning. We'll talk about that later. Thanks.
Actuality, business intelligence. The path to enlightenment.